Okay, warm up. We have two separate sections of questions and two different things that we know about the picture to the right. For the first three questions, the only thing we know about any of the lines in that picture is that lines M and N are parallel to each other. So I'm going to go ahead and mark those two lines as parallel. So lines S and T are transversals. They look like they could be parallel, but they did not tell me right here that they're parallel, so I cannot make that assumption. I want to know whether angles 6 and 1 are congruent to each other. Are angle 6 and angle 1 congruent? No, those are not congruent angles. Angle 6 is an interior angle because it's in between my two parallel lines, but angle 1 is not in between my parallel lines. It's an exterior angle. The only kind of special angle pair that we have when one is interior and one is exterior is if they're on the same side of the transversal. So angle 2 and angle 6 are congruent, but angle 1 and angle 6 are not. So this would be a false statement. What about angles 12 and 13? Are those two angles congruent? Are they interior or exterior angles? Interior. They are in between my two parallel lines. Same side or opposite side of the transversal? Opposite side. These are congruent to each other. These are called alternate interior angles. They're on opposite sides of the transversal, so that's where that alternate comes from, and they're both interior angles. So this one would be true. All right. Number 3, angles 4 and 11. 4 and 11 are supplementary angles. If we knew that lines S and T were the parallel lines, this would be a true statement. But what we know here is that angle M and angle N are parallel to each other. But we do not know anything about lines S and T. They make it look parallel in the picture, but we don't know that for certain. So looking at this angle and this angle, they only touch one of my parallel lines. They don't touch both parallel lines. And they touch two different transversals. So this one's actually false here. If they were touching both of my parallel lines, so if instead of angle 11, we said angles 4 and 5, those would be supplementary. But because we're only touching one parallel line, that's why that one's false. All right, down to number 4. We still know that lines M and N are parallel, but now we're also adding to it that S and T are parallel to each other. So now I know that these guys are parallel. Would that make angles 6 and 15 congruent? Yes. They are in between these two lines that we now know are parallel, and they're on opposite sides of the transversal. Can anybody tell me what this particular special angle pair would be called? alternate interior angles. Next up is angles 4 and 13. So here's angle 4. Here's angle 13. I want you to look really carefully in the center. What kind of a shape have we made in the center of these lines? I'm looking at this thing right here. What would we call that shape? How many sides does that inside shape have? Has 4 sides. So one name for it could be what? Quadrilateral. It's a parallelogram. Look at the top and the bottom. They are parallel to each other. And the left and the right are also parallel to each other. So this inside shape here is a parallelogram. Angles 4 and 13, are those congruent or not congruent? They are congruent. Because they are what? They are opposite angles of parallelogram. Yes. So this is true. Opposite angles of a parallelogram are congruent. And now the last question. The last question is exactly the same as what other question on here? Number 3. Same exact question. But for number 6, I have, remember, additional information. I know that not only are M and N parallel, but I know that S and T are parallel. So we have this parallelogram in here. And I want to know about angles 4 and 11. What could we call those angles? They are supplementary because they are what special angle pair in a parallelogram? I'm looking for a word that starts with a C. They are consecutive angles. They're both on the top of my parallelogram. And in a parallelogram, consecutive angles are supplementary. So this would be another true statement. Consecutive angles of a parallelogram are supplementary. Nice work on the warm-up today. We're going to be doing quite a few more true-false warm-ups as we learn different properties about different quadrilaterals. I want to go ahead and pull your notes out. We're going to be on page 6 in your notes. And once again, I threw another new homework at you guys. Sorry. We'll go back to every other day after this one. Not going to be homework, homework, homework. Homework number 3, the one that you guys picked up yesterday, is due tomorrow. We're going to have some work time towards the end of class before D lunch where you can work on homework number 3. Remember, that was just the front side, so it should be a fairly quick homework. And then homework number 4, what you guys picked up on your way in the door, that one's not due until Monday. That one is over rectangles. We're going to be talking about rectangles today and tomorrow. Did you have a question? Yes. So tell me what you guys know about rectangles. It's a quadrilateral. It has 4 sides. Absolutely true. What else do you know about rectangles?
2 sides are bigger than the other sides.
Can be. Doesn't have to be. But the way this one is drawn, two sides are bigger than the other two sides. What else do you know about rectangles? All four angles are right angles. Are opposite sides congruent? Yes. In a rectangle, are opposite sides congruent? Yes. Are opposite sides parallel? Yes. They're like railroad tracks. They're never going to cross each other. They're never going to touch, no matter how far out you extend those lines. So the definition for a rectangle, this is a very special type of parallelogram. It meets all the same requirements for a parallelogram. With the addition of having four right angles. So because a rectangle is a special type of parallelogram, it meets all the same criteria of a parallelogram. So the sides, both pairs of opposite sides, are parallel and congruent. So let's go ahead and mark that on our rectangle right now. Left side is congruent to the right side, and left side is parallel to the right side. The top is congruent to the bottom, and the top is also parallel to the bottom. This is exactly the same as a parallelogram. What did we know about the diagonals of a parallelogram? What did we learn about the diagonals in a parallelogram? They bisect each other. So the same thing is true in a rectangle. The diagonals bisect each other. And because of those four right angles, they are congruent. So the first part is just like a parallelogram. And then we have one more characteristic that is special for rectangles. So I'm going to go ahead and draw in the diagonals. Opposite corners get connected with my diagonals here. This diagonal is being bisected by the other one. And because those two diagonals are exactly the same size, when I cut the other diagonal in half, its smaller pieces are exactly the same size as the first diagonal cut in half. I want you guys to look carefully now at one of the little triangles that has been formed inside my rectangle. I'm going to look at the bottom one, but we could look at any of the little triangles in here. What type of triangle has been formed by those two half diagonals and the bottom of the rectangle? Close. I don't know that it's 45-45 because I don't know that that diagonal is bisecting my angle, but I like what you're looking at. It's an isosceles triangle. These two sides are congruent to each other, which means it's also going to have two angles that are congruent to each other. So this makes an isosceles triangle. So if I know how big the diagonals are, I could use Pythagorean theorem to find a missing side. If I know how big one half diagonal is, then I know how big all of the half diagonals are. And I can use this property to find missing angles also. If I know this angle up here, I could use properties of isosceles triangles to find both of these angles down here. And again, that's true about all the little triangles that are inside this rectangle. Notice all of them have two congruent sides, so they will all be isosceles triangles. All right, last thing. You guys already told me this already, but let's see if we can remember it. Tell me about the angles in a rectangle. They're all 90 degrees. All four angles are right angles. They are 90 degrees. I want to look at two problems with you guys, and then the remaining time will be homework time. We're going to look at examples 2 and 3. So on example number 2, it says the coach is making the basketball team run a new drill along the diagonals of the court as shown. If BC, this side right here, is 94 feet, and FC, this diagonal right here, is 106.5 feet. Give me just 1 second, Sylvia. Yeah. Find the length of DG. So this is the thing that we want to find. What did we just learn that's special about the diagonals of a rectangle? Yes, and I'm looking for the are congruent part right here. They bisect each other, fantastic. They are also congruent to each other. What are the names of the diagonals in this picture on the basketball court? FC and BD. So BD is congruent to FC. These are the diagonals of the rectangle. And so that means their measurements are equal. The measurement of segment BD is equal to the measurement of segment FC. We're going to need to use that information now to help us find the length of segment DG. So looking at that picture, what relationship would DG have to this whole diagonal here? The whole thing is 106.5 feet, but I want to know what's the relationship between this little piece right here and the whole diagonal. It's 1/2 of the whole diagonal, because remember, it's being bisected. So DG is equal to half of BD. Because the diagonals bisect each other. Diagonal BD is exactly the same size as what? FC. DG is equal to half of, and then we're going to do a substitution here. We're going to put FC in the place of BD because they are the same exact size. And I want to make that replacement because I know how big FC is. How big is segment FC? 106.5 feet. So if I can find half of 106.5, then I know exactly how big DG is. What is half of 106.5? 53.25 is absolutely correct. I'm going to try to move my work around here. I'm going to go back to the way it was. It looked better over here. All right. So DG is equal to 53.25. Would we need units with that? Feet. All right, I want to look at number 3, and then that'll wrap us up for today. It says quadrilateral ABCD is a rectangle. And then it goes on to tell me that the measurement of angle BAC is 3x plus 3. So BAC. This angle right in here is 3x plus 3 degrees. And then it goes on to say that the measurement of angle ACB is 5x minus 1 degrees. So from A down to C, and then up to B. So this angle right in here is 5x minus 1 degrees. They said this is a rectangle, right? So how big is this whole angle up here? 90 degrees. What kind of a shape are we looking at here? A triangle. What do we know about the angles in a triangle? They add up to 180 degrees. So 3x plus 3 degrees plus 5x minus 1 degree plus that 90-degree angle up in the corner of my rectangle has to add up to 180 degrees. We're not distributing anything to the parentheses. We're just adding pieces together, so we can rewrite this without the parentheses in place. 3x plus 3 plus 5x minus 1 plus 90 equals 180. And now on the left-hand side, we have to collect all of our like terms together. How many x's do we have? I have x written down in 2 spots, but how many x's when I collect them all together?
10.
Not 10. 8. Yep, 3 plus 5. It's okay. So I have 8x, and then I have to collect my constants together. I have a positive 3, and then a minus 1, and a plus 90. What is 3 minus 1? 2. Plus 90 more? 92. So 8x plus 92 equals 180. What would I want to do now? Subtract 92 from both sides. What is 180 minus 92? 180 minus 92. What did you say? 88. So when I divide both sides by 8, I find out that x is how big? X is 11. Very nice work today. We have about 13 minutes of homework time before the D lunch bell rings. Remember, this is just the front side. There are 8 problems total. The first 6 problems, I want you to tell me whether or not it is a parallelogram. They all look like parallelograms, but I want you to tell me whether or not, using the tests that we learned yesterday, whether those figures are actually parallelograms. And then the last 2 problems were similar or are similar to the problems that we had on today's homework. You have to use properties like diagonals bisect each other, opposite sides are parallel and congruent, opposite angles are congruent, so that you can solve problems 9 and 10. Please let me know if you guys have any questions.